So this is one of those rare occasions where 3 videos is a necessity. I apologize for the extra amount of time in notes, but these are pretty powerful triangles. Okay, so let's go with the second proof here. So now let's prove that an equiangular triangle is also equilateral. So now it's kind of backwards. Now we know the angles are congruent. Prove that these sides are congruent. Okay, so step 1 here. Again, let's just use a pair of angles. So if angle G is congruent to angle H, so if G is congruent to H, that means that GH is the base. That means that the other 2 sides, which would be, we call this what? GJ and HJ, they'd be congruent. Then GJ would be congruent to HJ. And this would be by the converse to the isosceles triangle theorem. All right, step 2 is very similar. So now we say if angle H is congruent to angle J. So now we're looking at H and J. So now this bottom side is the base. Then GJ and GH would be the congruent sides. Then GJ would be congruent to GH by the converse to the isosceles triangle theorem. And now we're going to take these 2 statements and combine them using the transitive property, right? So you see that GJ is congruent to both HJ and GH. So that means HJ and GH are congruent to each other, and all 3 are congruent to each other. So GH is congruent to HJ, is congruent to GJ by the transitive property. And there you go. So believe that every equilateral triangle has 3 congruent sides and 3 congruent angles because we just proved it. All right, so let's do a couple problems and we're done. All right, so this first one here. So it says if the measure of angle CBD equals 130, what is the measure of angle BAD? So where is CBD? CBD is right here. This is 130, and they want BAD, which is this angle right there. What is that measure? So first and foremost, you should recognize right here, this is an equilateral triangle. So immediately you should know that all of these angles are 60. So 60, 60, and 60. So triangle ABC is equilateral. So the angles are 60 degrees. Angles are 60 degrees. Okay? So now how's that going to help us? Well, now we can use this idea here called angle addition, all right, to find out what the measure of just this angle right here is in purple, ABD, okay, ABD. And we're going to do that by taking 130 and subtracting 60. So to find the measure of angle ABD, we're going to take 130 and subtract 60. That's 70 degrees. So this angle right here is 70 degrees. So let me draw that picture out to the side here. So this is A, B, D. Again, this is the angle I want, and I know that this is 70. Now there's a couple markings here and here. These 2 dashes right here on AB and on BD, these 2 sides are congruent. So this is an isosceles triangle. So triangle ABD is isosceles, which means that these 2 angles down here, I'm going to use green because I like green, the angle at A, which I want to find, and the angle at D, they're congruent. So again, this is that whole x and x idea, right? We now know that x plus 70 is 180. This is 2x plus 70 is 180. All right, combine those 2 x's. Subtract 70, 2x equals 110, and divide by 2, and x is 55. And that is exactly one of the angles we wanted to find. So the measure of angle BAD is 55 degrees. So what a cool example that incorporated both an equilateral and isosceles triangle. Okay, and then let's do one more together and we'll be done. All right, so now it says, what is the measure of angle U? All right, so if we look here, angle U is right here. We want this angle measure, okay? So notice we have two triangles, all right? The first one here, STV. Now triangle STV is isosceles, right? I'm going to draw it right here. So this is my first step. Triangle STV is isosceles. I know that because it has two sides marked congruent, ST and SV. This vertex angle is 72 degrees, so I believe I can find these two angles because the angles at T and V are congruent. Okay? So I'm going to call this X and X. So X plus 72 is 180. 2X plus 72 is 180. Subtract 72 on both sides. 2X equals 108. And divide by 2. Your X value is 54. That is the angle here and here. That is this angle right here and this angle right here. Okay. So now we can do this a couple ways, okay? So I can use the fact that right here is a linear pair. I can find this angle right there, the angle TVU, and then do the same thing we just did. Or I'm going to be clever, right? Watch how clever I am. So let's use triangle TVU, right? It's isosceles because you have the markings here and here. So it's an isosceles triangle. But let me draw it like this. TVU. Let me extend side VU to include this 54-degree angle right there. So in TVU, these two sides are congruent. So angles T, I'll use two arcs, and angles U will be congruent. So let's call them like Y and Y. Well, 54 degrees is an exterior angle. We have this thing called the exterior angle theorem for triangles that says the measure of the exterior angle, 54, is equal to the sum of its two remote interior angles, which would be the Y and the Y. So it's a clever way of doing this. Okay? Y plus Y is 2Y, so 54 equals 2Y, and we'll divide by 2. And Y is 27. And that is the measure of angle U. The measure of angle U is 27 degrees. Now again, as I said up here, you could use the linear pair idea to find this angle here at V, and then do the same thing we did for triangle STV for triangle TVU. But just kind of show you a different way of looking at things and bringing back old ideas. Okay? All right, so hopefully this helps. Good luck on your practice, and we'll see you next time.